Welcome to this podcast on e-communications or electronic communications. This will involve a discussion about questions related to networks and to the internet in computing. These topics were from question 5 of the 2024 Computer Applications Technology or CAT November exam. There are 3 ways you can engage with the content of this podcast. If you want to test your knowledge, then download the questions covered in the video. The link is in the PDF in the video description. Then attempt these questions. And then once you've done that, come back and listen to the discussed answers and compare them with what your answers are. Or number 2, if you want to use the podcast to learn new information, then listen to the discussion first. Then download the questions from the document. The link is in the video description. And then test yourself to see how much you remember from the discussion. And the third way is to simply enjoy the discussion and learn more about e-communications. So now let's hear what our podcasters have to say on e-communications.
Welcome to the deep dive. So glad you joined us today. We're going to pull back the curtain a bit on the digital world you're interacting with, well, pretty much constantly, especially if you're studying computers in high school, or maybe you're just curious about all the tech buzzing around us. You're definitely in the right place. Today, we're doing a deep dive, one designed specifically for you. We've got this stack of insights about internet and network technologies. And really, our mission is just to cut through some of the noise and get straight to those essential nuggets of knowledge. We'll look at what makes your internet fast or, painfully slow sometimes. Even how a simple browser tab works, and definitely how we try to keep our digital lives secure.
Exactly. And this isn't just about memorizing definitions. It's about getting a quick, but still, a really thorough understanding of these core ideas. We want to spark some of those aha moments where things just click. Because let's be honest, in today's world, actually getting how this stuff fits together, it's not just useful, it's pretty crucial for navigating everything online.
All right, let's kick things off with something we all want. High-speed internet. When you hear that term high speed, what jumps out? Like instant movie streaming, or maybe zero lag online gaming. What actually makes an internet connection feel fast?
That's a great question. The speed you actually experience, it largely comes down to the physical medium that's carrying the data signal. And there's actually quite a fascinating range of technologies powering our connections these days. First up, and probably the gold standard right now, is fiber optic cable. This stuff is incredibly fast and super reliable because it transmits data using, pulses of light, not electricity.
Light, okay, so that's different from the usual cables.
Totally different. Then you have copper cable, often called coaxial cable. This is still really common for cable internet in lots of homes. It's pretty robust, widely available. Different characteristics than fiber, though. And we also have DSL, digital subscriber line. It cleverly uses existing telephone lines for internet. Maybe not fiber fast, but it's a solid option if that's what's available.
Okay. And what about plugging directly into the network? At school or for gaming?
Yeah, for those wired connections within a local network like your home or school, that's where Ethernet comes in. That's the cable you plug right into your computer or console for usually the most stable and fast local connection.
Right, the reliable plug-in option.
Exactly. And then, of course, for mobile freedom, we use radio waves. That's your 4G, your 5G, your LTE cellular networks. Great for being on the go, but speed can vary a lot, depending on signal strength, network congestion. And finally, let's not forget satellite. For really remote areas where cable or cell signals just don't reach, satellite connections beam internet down from space. It can be a vital lifeline, really.
Wow, that's quite a list. Fiber, copper, phone lines, radio waves, even satellites. But how do these different things, light, electricity, radio, how do they actually deliver that smooth experience we expect? When streaming or gaming or on a video call, it feels like magic sometimes.
Definitely not magic, but it's clever engineering. Each medium has a different capacity, how much data it can carry, and how fast. Fiber, using light, is immune to the kind of electromagnetic interference that can mess with copper signals, so it's not just raw speed.
It's also about stability. Less prone to dropouts.
Precisely. Incredible stability and signal integrity, even over long distances. Copper and radio waves. They're effective, sure, but more susceptible to signal degrading interference. That kind of limits their top performance, especially further away or if lots of people are using it. So the medium itself really sets the baseline for speed and reliability.
That makes a lot of sense. Okay, so speaking of wireless, let's shift to how all our wireless gadgets connect. Think about your home Wi-Fi. Your
Yeah.
phone, laptop, smart speaker, they're all talking wirelessly. What's the key bit of kit making that happen? We're talking about the wireless access point, right? Or WAP.
Yep, the WAP. Put simply, a wireless access point is just a device that lets other wireless devices connect to a network, whether that network is wired or wireless itself. It's a standard piece of hardware now in homes, schools, businesses, everywhere, really.
So it's like the Wi-Fi broadcaster.
Essentially, yeah. Think of it as the translator and broadcaster. It takes the internet signal, usually from your router, via an Ethernet cable, and then it broadcasts that signal wirelessly. That creates the Wi-Fi network your phone, tablet, laptop, all those smart devices connect to. It's the bridge, basically, making sure your wireless signals can talk to the rest of the network and, ultimately, the internet.
Kind of like an air traffic controller for all the Wi-Fi gadgets in the house.
That's a great analogy. Yeah, directing all that wireless traffic smoothly.
Okay, cool. So from connecting to the internet, broadcasting it wirelessly, there's clearly a lot of information flowing around. And just like we want to keep certain conversations private, this brings us to a really critical topic. Network security. Why is securing a network just so fundamentally important, especially for places like schools or businesses handling sensitive data, or even just for us at home?
Oh, it's absolutely paramount. Without strong defenses, all that information is just vulnerable. For schools, you're talking student records, grades, maybe research data, businesses, financial info, customer data, intellectual property, huge stakes. And for you, personally, it's about protecting your photos, your banking details, preventing identity theft. It affects everyone.
So how do we build those defenses? What are the tools?
There are several key layers, actually. It's not usually just one thing. First up, you have firewalls. Think of them as digital bouncers at the door of your network. They meticulously check incoming and outgoing traffic against security rules.
So they decide what gets in and what stays out.
Exactly. They're often the first line of defense. Then there's a VPN, a virtual private network. This creates a secure, encrypted connection over a public network, like the internet.
Like a secret tunnel through the public internet highway.
That's a perfect way to put it. It hides your data from anyone trying to snoop. Then we have the basics, but they're crucial. Access controls, authentication, logins, good old usernames and strong, unique passwords.
The first hurdle for any attacker.
Absolutely. Your first and maybe most important defense sometimes. Beyond that, antivirus or anti-malware security software actively hunts for and neutralizes malicious software. It's like your device's immune system, constantly scanning. And to protect passwords, even if they are somehow intercepted, we use security protocols for password encryption. They scramble passwords into unreadable code.
So even if someone grabs the file, the password inside is just gibberish.
Ideally, yes. And finally, the data itself, network data and files can be encrypted too, whether it's just sitting stored somewhere or being sent across the network.
Wow, so it really is about building these layers, not just one magic bullet.
Definitely. It's layers of defense. And here's the thing. The strongest firewall doesn't help much if your password is password 123.
Huh. Right, the human element.
Exactly. Technology gives us the tools, but user awareness, good habits like strong passwords, not clicking weird links, that's just as vital. It's a mix of tech and behavior.
That makes total sense. Okay, switching gears, but let's talk intranets. These are basically internal networks for a company or maybe a school, right? For sharing resources securely, just for employees or students.
That's the idea, yeah. A private internal web space.
They sound super useful, like a mini internet just for the organization. So here's an interesting question. Why would a company choose not to use an intranet? They seem so beneficial on the surface.
That's a really good question, and it gets to the heart of practicality versus potential. The most advanced solution isn't always the best fit. There are actually several solid reasons why a company might skip having an intranet. For starters, the company might just be too small to justify the cost.
Money.
Yep. Intranets often involve licensing fees, plus the cost and effort to set them up, integrate them with other systems, and crucially, maintain them. For a small business, that might just be overkill.
Okay, cost makes sense.
What else? Well, there's the security angle, too, ironically. Staff might bring in unauthorized devices, personal laptops, phones, USB sticks. And if those aren't secure, they could inadvertently infect the intranet with malware, bypassing other defenses. It's the BYOD Bring Your Own Device challenge.
Right, introducing unknown risks into the secure garden.
Exactly. Plus, intranets aren't set it and forget it. They require ongoing integration and maintenance. Updates, troubleshooting, content management. It takes dedicated resources.
So it's an ongoing commitment, not a one-time setup.
Definitely. And then there's the user experience. This is a big one. Internets can often be overly complex for employees to navigate. They might find them confusing, or they can be inaccessible or just plain challenging to access for people working from home or trying to use their personal PC or smartphone. And they rarely have good offline functionality, which is a pain if internet access is spotty.
So if it's hard to use, people
Well,
just don't use it.
Pretty much. And on top of that, employees need to be trained to use it effectively. That's another investment of time and money. So yeah, sometimes simpler, maybe cloud-based tools, or even just shared drives and good communication practices might actually be more effective and less costly than a full-blown intranet. Convenience and usability can trump features sometimes.
Fascinating. Finding the right tool for the job, even if it's not the most complex one. That's a really important point. Okay, let's zoom out now. Big picture time. We've talked about the internet's building blocks, security. But what happens when all these technologies start merging? Not just online, but in the physical world too. This brings us to a huge concept, the Fourth Industrial Revolution, or 4IR. Have you heard this term bouncing around? What do you even picture when you hear Industrial Revolution happening now?
It's a big concept, for sure. The Fourth Industrial Revolution, or 4IR, describes this massive ongoing transformation in how we live and work. At its core, the definition is about the integration of technologies across the physical, digital, and biological worlds.
Physical, digital, and biological. Wow. Okay, unpack that a bit.
Yeah, it's about these technologies blurring the lines between those traditionally separate areas. It's not just about individual cool tech like artificial intelligence or the Internet of Things, smart devices talking to each other or breakthroughs in biotech and genetics. It's about how all these things are converging and interacting in totally new ways.
Can you give an example?
Sure. Think of a smart factory where machines use AI to optimize production on their own, communicating constantly. That's physical and digital merging. Or wearable tech that tracks your health signs, physical analyses the data digitally, maybe even interfaces with biological sensors and sends alerts to your doctor, or even advances in gene editing technology that's directly impacting the biological sphere using digital tools.
Okay, I see. It's the combination that's revolutionary.
Exactly. It's this massive shift impacting industries, economies, daily life, everything, really, at a speed we haven't seen before. For you guys as students, this is the world you're stepping into and the world you'll help shape.
That's kind of mind-bending. The integration of physical, digital, biological. Feels like the future is arriving fast. Okay, let's bring it back down to earth. Something way more familiar, something we probably all do like 100 times a day without even thinking. Tabbed web browsing. We all do it, right? Open like 15 tabs when researching something or just browsing around. But have you ever stopped to really think why that's so useful? Why did tabs take over?
It's one of those brilliant, simple innovations that just fundamentally changed how we use the web, didn't it?
Yeah.
The advantages are super clear when you break them down. First, obviously, it's just incredibly efficient use of screen space. Instead of a messy desktop full of separate browser windows, everything's tucked neatly into one window. Just click between tabs.
Definitely cleans up the screen. What else?
Well, that leads directly to faster navigation. You save time accessing websites because switching tabs is instant, no opening new windows, minimizing, maximizing.
Click, click, click.
Exactly. And the core benefit, of course, is just access to more than one website at the same time. Seems basic now, but it was huge. Plus, modern browsers let you organize tabs into groups, which is amazing for research projects, right? Keep all your sources for one topic together.
Oh yeah, tab groups are a lifesaver. Seriously.
They really are. And some browsers even allow multiple home pages that all open up at once when you launch. Power user stuff, but handy. But I think the real genius is how it enables convenient multitasking. It shifted how we approach information online. We went from a sort of linear, one thing at a time model to being able to juggle multiple streams of information simultaneously. It reflects how our brains often work, jumping between related ideas.
So it's not just tidy. It actually changed our workflow and how we process digital info.
Wow. Even tiny design choices can have a massive impact. Okay, now for a universal pain point, something that makes everyone sigh. Slow internet. Ugh, we've all been there, waiting ages for a video to buffer or that huge project file to upload right before the deadline. What actually causes those frustrating slowdowns? I always want to blame my internet provider, but is it sometimes my own fault? Like my old laptop or router? Oh, absolutely. It's rarely just one single culprit. It's usually a combination of factors conspiring against your speed. Some are obvious, like file size. Bigger files just take longer to transfer, naturally. Or if you have multiple files downloading or uploading at once, they're all competing for the same slice of bandwidth.
Right. Trying to do too much at once.
Exactly. And your bandwidth size itself is key. That's the maximum capacity of your connection plan from your ISP. If you're on a lower tier plan, everything will feel slower, especially with multiple users or devices.
Okay, makes sense.
What else? You hit on a big one. Background applications running. So many apps on your computer or phone are using bandwidth without you actively clicking on them. Updates, syncing, notifications, it all adds up.
Sneaky bandwidth hogs.
Totally. Then there's the type of internet connection itself. DSL, cable, fiber. As we said, they have different inherent speed limits. And the quality, stability, and reliability of that connection matters too. Plus, general network traffic and congestion.
Like rush hour on the internet highway.
Pretty much. If everyone in your neighborhood is streaming high-def movies at 7 p.m., speeds can dip for everyone sharing that local infrastructure. Even physical things like your distance from the router or how far you are from the service provider's equipment can cause signal degradation.
So getting closer to the Wi-Fi box can actually help.
It often can, yeah. And your own hardware capabilities or router, your modem, are definitely crucial. An old router might not be able to handle the speeds your ISP is actually delivering. It becomes a bottleneck.
So upgrading the router isn't just a gimmick sometimes.
Not at all. It can make a real difference. Then there are things your ISP might do, like shaping, prioritizing certain types of traffic, maybe video streaming over file downloads, or even throttling, where they intentionally slow your connection down, perhaps if you've used a certain amount of data.
Wait, they can just slow me down on purpose.
Sometimes, yeah, it's often in the fine print of the service agreement. It manages network load. And finally, the overall capacity of the ISP's infrastructure plays a role. Can their network handle all their customers efficiently? And yes, back to your point, the efficiency of your own devices. An old computer or phone just might not have the processing power to handle data as fast as it's coming in.
Wow. Okay, so it really is a complex puzzle. Lots of places things can slow down between the internet and my screen. Good to know it's not always just the ISP. All right, let's wrap things up with something super practical, something you use constantly, especially for school and eventually work.
Yeah.
Email. Let's use an example. Imagine John sends an email. The subject line just says, take note. He marked it high priority and he flagged it. First off, that subject line, take note. Why is that? Well, why is that a bad subject line?
It's bad because the subject line does not indicate the topic of the email. Simple as that. A good subject line should be clear, concise. It should tell the recipient immediately what the email is about. Meeting agenda, question about project X, homework submission, take note, gives zero context. Is it urgent? Is it spam? Is it important homework? You have no idea without opening it. It's vague, unhelpful, and likely to get ignored or lost.
Right. Clear communication starts right there in the subject. Okay, so John's email, he marked it high priority and he flagged it. What's the difference between those two things? They sound similar, like ways to mark importance. Are they distinct?
They are very distinct, yeah. And understanding the difference is really key for managing email effectively. High priority is something set by the sender. When John marks his email high priority, he's signaling to the recipient, hey, I think this is important, please look at it soon.
So it's the sender saying, this is urgent to me.
Exactly. It's an attempt by the sender to convey urgency. Now, flagging, on the other hand, is an action taken by the recipient. It's a tool for you to organize your own inbox. You might flag an email to remind yourself to reply later, or because it contains info you need for a project, or just to make it stand out.
So flagging is my personal to-do or follow-up system for my inbox.
Precisely. It's for your organization. The sender doesn't even necessarily know you've flagged it. High priority is sender intent. Flagging is recipient action.
And what happens if people just mark everything high priority? Does it lose its meaning?
Oh, absolutely. That's the danger. If someone constantly cries wolf by marking every email high priority, people quickly learn to ignore it. If everything's urgent, then nothing is.
Use it sparingly then.
Definitely. So, yeah, understanding these little distinctions, it helps us send clearer emails and manage our own inboxes way more efficiently. Less stress, hopefully.
What a journey today. Seriously. From the hidden wires and waves carrying our internet to keeping things secure, the future of tech integration, even down to email subject lines. We really have taken quite the deep dive.
And hopefully understanding these foundations gives you a bit more power, helps you navigate this digital world more effectively, more securely, and maybe with a bit more appreciation for just how complex and interconnected it all is. You're not just users, you're part of shaping what comes next.
Absolutely. Which leads to a final thought to chew on. As technology keeps weaving itself deeper into our physical, digital, and even biological lives, and everything gets more connected, what new responsibilities do you think we'll have? as digital citizens, especially balancing all this amazing convenience with the need for security, privacy, and just clear communication in this rapidly changing world. Something to think about. Thank you so much for joining us on the Deep Dive today. Keep exploring, keep asking questions, and keep learning about the incredible tech all around you.
It would mean a great deal to us if you could click on that subscribe button and share us with other friends as well. Help us to help other people with their computer terms. Remember us on TikTok at Mr. Education, and don't do it the long way, do it the Mr. Long way.